Greetings, Wentworth classmates. This is Dave Tassinari, and this is the final project plan presentation for our project management capstone class. So what I want to go through here is the overall background about my project and also the way that I've structured it in anticipation for handing in the project plan, which is due in 3 weeks. So without further ado, the name of the project and the name of the product that I've decided to use for this assignment is called Nimbus, which is the product is going to be cloud-based cross-platform project management suite. Okay, so what that really means. Project managers use various tools during the life cycle of a project to track the progress, the schedule, the risk assessments, all of the things that really go into the project plan and follow through throughout execution. Many different software things are used, Microsoft Project being one of them. There's quite a bit of homegrown software that's used in various companies. And other companies, especially software companies, use a lot of agile tools or methodologies related to agile development and agile project management that really don't lend themselves well to cross-platform use, meaning that a project manager cannot necessarily access the same data and modify it, track it from a mobile device, also from the web, and then from the PC. So really, that's kind of a need that I see, and that's born out of just the experience that I've had working with both web-based tools and with mobile tools. They don't necessarily work well together, so I thought a great idea for a project would be to show what it would be like to develop a software project that's cross-platform and plan the whole thing out and have the project be useful for project managers. So that's what Nimbus is. The project itself, like I just basically said, is accessible through Android, iOS, or the web. It'll store data in the cloud, accessed wherever, created using the data connection on any device. The application will have the ability to query the database dynamically so that you can get calculated visual metrics. The key thing about this project and the idea that I had was that in agile project management, traditional metrics or traditional KPIs are not measured or not measured easily. Now, the issue with that is most companies that are not startup software development companies or larger software development companies that really are looking to change the way that they've traditionally managed projects with waterfall, those types of companies don't really understand the metrics that come with agile methodologies. They don't understand things like burn down. They don't understand things like cumulative flow. It's very difficult to show a C-level executive those types of metrics and have him, just by looking at it, understand what the health of the project is. So they're very used to things like EVM, earned value management. They understand the estimate at completion. They understand the budget at completion. They understand planned value versus earned value. So the challenge here was to create a software tool that allows agile methodology during execution, but during project evaluation, and preferably real-time project evaluation based on input data, that anybody who is traditionally used to the PMI, waterfall KPIs, to view those as translated by the use of an agile executed project. So that's what this is, and I'll go into that a little bit more detail, what that really means in a few minutes here. So on top of just designing a tool that will allow a project manager to use agile methodologies and execute a project as such, and then actually show the data with traditional waterfall KPIs, I actually executed this project. I simulated the execution of it, meaning I planned it all out. I put some fake data in there just to show that it is possible to track in real time the idea. So we'll go into that also in a few minutes here, but the project itself will be executed using Agile Scrum. So what are some features of that? Well, product backlog items. This is every piece of work that has maybe a bunch of tasks associated with it, but it is a user story, something that is needed, a feature of the tool, etc. Those are identified during scoping, placed into a backlog, which is basically a bucket of tasks, a bucket of stories which have tasks assigned. So there's a couple of layers there. Work is organized into sprints, iterations basically, short periods of times over which the PBIs are assigned, they're completed. What is a PBI? A PBI is defined as a small, testable, estimable, and independent piece of work, a collection of tasks, essentially. They are defined with a point scale to illustrate level of effort. Okay, so what the point scale is the point scale is essentially, a lot of people use a modified Fibonacci sequence where, you know, a very small task would be 1, next size up from that would be 3, 5, 7, 9, and then a very large task would be something like 40. When tasks get super large like that, they're usually broken down into epics, which are collections of user stories. But we don't get into that level of detail in this particular project plan because it's not really necessary. This is seems like a large project to execute, and it probably is, but my high-level look at it and my high-level planning of it covers a whole bunch of different platforms, and it's possible that I left things out, but with Agile, it's absolutely normal to leave things out. It's absolutely possible that the scope changes later on during project execution, where some user stories get substituted out for others, that it's determined that maybe the customer changed their mind, maybe we didn't know that there was going to be something in the market that changed, etc. So there's a lot of flexibility in the methodology. So the product, it aims to provide the PM with a system that allows for waterfall KPIs, executing Agile methodology projects. So they're usually omitted in Agile projects because they use other things like burn down, cumulative flow, and iteration health. Organizations and managers are usually not up to speed with that in a lot of big organizations. Mine included, by the way. I mean, this is something that I struggled with at work, literally trying to illustrate to managers what the project health is for the projects that we have in execution. It's very difficult to explain to them without a formal education or a lot of investigation on what Agile is and how it works. So I found this to be useful, and I believe that going forward I will be using something similar to this to track my own projects that I execute in Agile. So proof of concept included. How will we use Agile, which is not normally tied to time in the form of hours, and ultimately the cost associated with those hours, to measure and evaluate health? Well, this is a great question. To prove the viability of the concept associated with the tool, we have to bend the rules for Agile a little bit to allow for the metrics to be generated. So consider that each story, okay, each product backlog item has tasks associated with it, and these tasks have hours. So each user story will have points to indicate the level of effort in a traditional Agile environment. If we use the sum of the task hours associated to the user story and use a multiplier to determine the story points, you can take a look at the collection of story points as cumulative cost. Okay, so what it really means is that this multiplier, a fictional number, I use 5, some people can use other ones, it doesn't really matter, but the point is it must be consistent across the entire planning of the project. So how does it work? We organize the PBIs into sprints, assign tasks to contribute to the story. In this example, the story has one task. Okay, so we're looking at the architecture spec, and then the task itself is to prepare the architecture spec. Okay, now you can see that the task estimate that we're looking at here is 15 hours. So we guess that it's going to take 15 hours to prepare the architecture spec. So that translates to task hours for the architecture spec user story, which is basically the owner. So this prepare is the child, that's a task. Architecture spec is the PBI, that's the story. What we've done here is we have a multiplier of 5 that we use across the entire project. So the sum of the tasks associated with each story, in this case there's only one, so it's 15, and we divide that by the multiplier, which is 5, and you get story points of 3. So you can see this is consistent. I have 15 hours worth of tasks here, and I have 3 points. Now, the overall points here are now essentially, if you were to want to find out how many hours it would take and subsequently how much money it would take to execute all of the story points that were planned, It's very easy. You just take 81.2, which I've got here, and multiply that times 5, and that's how many hours you've planned. Okay, so by using this consistent multiplier across all of the planning in the project, we can execute with Agile, and we can report on earned value and planned value and budget at completion, estimate at completion. Okay, so that's how it works. So what's the project plan? Project plan is a collection of deliverables. Obviously everybody understands, hopefully everybody understands what a project plan is. Now for Agile, it's a little bit different. A WBS is not normally used. Okay, it could be used. I could take all of the user stories and just assign them some generic number, but that's not really the point of Agile. Agile, all of the tasks are independent, so there really aren't any uh, dependencies. There are no predecessors per se. There could be predecessors, but we don't really tie them up that much. When we define the PBIs, the goal is to be able to have multiple people working in the same sprint on different tasks that all contribute to the same theme or feature, okay, or initiative. So we try to make those estimable and independent and small and testable. So that's what I did to organize this project. So no WBS, but we still have the project charter, a risk assessment, and we have an agile EVM dashboard, a budget, project schedule, and return on experience. And I'll get it back to what return on experience is later on in the presentation. So the project charter includes all the relevant information related to the project to basically achieve a go, no-go decision by sponsors and stakeholders. If you have an idea for a project, this project has a sponsor, this project has a steering committee, this project has stakeholders that are going to make the decisions, managers that are going to decide whether or not you're funded or you're not funded. This project charter is what is shown to those people when you are looking for a go, no-go decision. So it gives a high-level look at scope, cost, risk, and benefit. Okay, so let's take a look at the one that I've set up here. My charter, it's got the purpose of the project, the executive summary is in there, supporting documentation is in there, the role of everybody and what the authorization is for the project, the objectives of the project, what the objective is, what's the expected benefit. All of this is detailed there. The expected benefit is measured right here. So when I'm looking at the iOS app, I want to know what is the benefit of having an iOS app for this particular application, and the way that I look at it is this is a market differentiator. There really is no tool out there that's cross-platform like this, at least that I could find in the market that was easy to use for this purpose. If you try to find one that will measure EVM and Agile, it's going to be very difficult for you. It was very difficult for me. I wish they existed, but I couldn't seem to find anything anywhere. Let's see. So the scope details, we're looking at what is in scope. Web source code, iOS source code, Android source code, and object model spec, which defines all of the objects that are shared between all three platforms. The architecture spec, how do we actually set up the back end of this application to talk to the cloud database, to talk to the individual devices that users are holding in their hand, and how do we handle account management so that you could log in from any device and share the same data. Also the project milestones and several other things that we go into a little bit later when we look at the live demo. The risk assessment. There's nothing different about the risk assessment for Agile as it is for every other project. The one that I set up is tracked with ID numbers, a description, what's being done to manage the risk. The risks are also measured by impact and likelihood, for which they are given a score. So the scores normally range from 1 through 5, 1 being a low risk, 5 being a high risk or a high impact or low likelihood, etc. What I do is I measure these impact and likelihood scores for each risk that I register, and then I multiply those two together to get an overall risk score. Now why do I do that? Because I like to have an overall view of all of my risks that I have on the project at any given time and in real time. So it lets me, as the project goes on, if I identify something while the project is in execution, I can quickly log that and then go back to my graph later on, which is normally a heat map, and I can see what are my highest priority risks based on that overall score. So this is the way that I organize it. We have the impact score of 1, likelihood score of 3. That means the overall risk score is 3. Anything that you see here that's a 9, that's a rather severe risk. When that shows up on the heat map, that's in the red. That needs to be addressed or mitigated as soon as possible, or we need to come up with a plan to how we're going to manage that. So the dashboard. Nimbus is organized to measure performance in real time. So I set this up so that I could simulate the project myself by changing the dates, by marking things complete, by setting up different things on when things are executed, moving tasks in and out of each sprint from the backlog as necessary. And in doing that, I needed a way to calculate on the fly the KPIs that are associated with waterfall. So all of the EVM calculations are run and the dashboard is updated automatically. So an additional benefit to this is that I can actually play with the schedule and I can move tasks around and I can simulate things going wrong. Like, for example, what would happen if I could only get the team to execute 5 out of the 10 user stories they were supposed to execute in this sprint? What would my EVM look like after that? So I can actually pull that off without actually having to go through a whole bunch of different calculations. I just will change that in the schedule and the EVM dashboard will update automatically. This is what the dashboard looks like. So it's essentially a web page that I wrote with, it has different links to the relevant documentation in the project plan. The charter, the schedule, the budget, the risk manager, and return on experience, which I call REX. So these are all the different sections of the project plan, and then here we have automatic graphs that are basically updated from this sheet down here, which is fed from the project schedule. So as things change in the schedule, things get statused, updated. This chart down here changes and my metrics change, and as my metrics change, my automatic graphs for my plan value versus my earned value versus plan value, my estimated percent complete versus actual percent complete, and my estimate at completion versus the budget at completion. So these things will automatically move when these values change, and these values will change when the schedule changes. So that's the way that it all ties together, and we'll take a look at that in a demo shortly. So the EVM worksheet, like I said, is linked to the project schedule, updates real time, tracks all traditional waterfall EVM calculations are all built into this. We do have user specified inputs such as the billable rate. So, whoop, I lost my, there we go. So the billable rate is in here. And the important thing for that is when you're tracking the actual cost, the billable rate is how much money it costs on average for all of the team members to contribute 1 hour. So if they contribute 1 hour worth of work, it costs the company or goes against the budget $100. The multiplier is also in here, which is 5, and then a base variance, which is a little bit, this is what makes the graph move. Okay, so without a base variance, you don't have, something needs to change by this number in order for the graph to move. Okay, so we have to have a number specified for that. So here's the budget. The budget's next. Organize the required funding to execute the project serves as a reference during execution to measure the performance of the fiscal resources used versus the planned scope. So what we've got here is, in a large company, what happens a lot of the time is that you have to separate your internal and external spend. Okay? The process for paying the bills is not the same for internal cost versus external cost. So this is the way that I set it up for this project as well, because I wanted to execute the project with both internal and external resources, very similar to the way that we did the simulations, where we had internal resources inside the company that were executing the project, but then we also had the opportunity to outsource either very heavily or just for some primary tasks, etc. So I did almost the same thing here. My resource cost internally, I left the same for $100 an hour, but I have 150 hours budgeted, and so I can determine what the cost is going to be for that, right, for the budget. And then my external developer cost, the third-party developer cost, was the same amount monetarily. In reality, that probably would go to a low-cost country and be more like $40 an hour, but that also depends on the experience of the developer. Nevertheless, I left it at $100 an hour. It doesn't really matter. for this, and it's not like I was going out for quotes from outsourcing partners or anything. But the important part is I've got 300 hours of resource cost external to the company, and I've separated that into its own line item, its own group of line items actually. I've also separated the third-party infrastructure costs. So there are certain things that are out of scope but are still necessary in the budget, such as hosting for the website, hardware, okay, computers that you need to buy to develop the software. Cloud services from Amazon Web Services are usually associated with a yearly cost. So I estimate whatever something might be for a yearly cost. Also, developer software licenses. It's required to have that. Okay, you have to pay for a subscription for licenses for each user that's on the project. So we anticipate that we've got a certain amount of developers working on this. The license costs will be rolled into the budget. So that's what the budget looks like. So the Agile schedule. The Agile schedule, it's a living document, okay? As things move in and out of the backlog or into the sprint, this thing changes all the time. The important thing at the beginning is to scope out the backlog. If you've scoped out the backlog and you don't continuously add things to the backlog, then there can be no scope creep, because at the beginning you know that the actual project will take the entire backlog to execute. So you know how many hours it's going to take, okay, if you plan it right. Moving things in and out of the backlog into sprints and taking things that are not in the backlog, they might be in a sprint, they didn't get completed, those go back to the backlog, and we'll explain why in a minute. So a PBI is not completed during the sprint, it's removed from the sprint and added back to the backlog. Usually the end of a sprint ends with a sprint retrospective meeting. Everybody takes a look, the team sits down, they say what went well, what went wrong, okay, what got accomplished, what didn't get accomplished. Those tasks get added back to the backlog, and then at the beginning of the next sprint everybody sits down for the sprint planning meeting and they look at the backlog and say, okay, well, this got put back into the backlog from the previous sprint. Is this still relevant? So it's important to visit that thing that didn't get done. If it was so important, why didn't it get done? And now the answer to that could be a lot of things like resources, etc. But sometimes it's just not as important as we thought, and things change during execution that make it less important than we thought. So that's normal. We will actually look at those all the time. We flag them in a different color or something and put them back there. But normally it's a resource issue. It's not that the thing wasn't important, but this does happen. So during backlog grooming, we evaluate those. If they're relevant, we'll put them in the next sprint. If not, they stay in the backlog. So the project is executed with daily stand-up meetings to look at 3 things from each member. I wrote 2 here, that's a mistake. It's 3 things. What did you do yesterday? What are you going to do today? And are there any impediments? So this is a pretty standard thing. The 3 questions get asked to every team member, go around the room, make sure that everybody can stay on track with what it is that they're assigned. If they don't have anything to do today, guess what? Now you get a new user story to do today. This is the vehicle to provide that work for those resources. So the questions, they ensure that they have work to do and that they can complete the work. If we have to make changes, we make changes. And at the end of this meeting, which is normally, we have a team of 10 developers right now, and I run meetings like this. They take 15 minutes. We go right around. Everybody says their answers to the 3 questions. If anybody needs to stay afterwards because they have ideas, they can stay after the meeting, and then we add those ideas to what we call the parking lot, which is basically, it's an incubator of ideas that may or may not affect the project. Maybe we missed something. Maybe we can substitute a user story out that we're not going to need in the backlog with the new thing that the customer may or may not want. So we use that parking lot for that. This is what the Agile schedule looks like. I did this in Smartsheet. I do not normally use Smartsheet for this. I use a much more robust Agile planning application, but so this was a new thing for me. But even though this is a waterfall style tool, I'm still able to use the sprints. I'm still able to use children elements and calculate upwards to determine all of the different things that I need to determine. I'm also not used to the Gantt when using Agile, but this is an automatic Gantt chart that basically tracks all of the different things that are going on. So we have sprints all in here, and we'll go into a little bit more detail why I did all the sprints. Normally, I never put more than one sprint in advance. We only plan 2 sprints ahead, and that's because things change so quickly in the development cycle that it becomes more work to revise than it is to add them from the backlog a sprint in advance. So return on experience. So what is return on experience? Well, this is my stab at lessons learned and a system to capture lessons learned during the execution of the project. So I didn't want to just look at lessons learned at the end. Sure, we have to look at them at the end, right? But what we always talked about was we have to make lessons learned part of the culture. We have to make, you know, this part of everybody's responsibility that's associated with the project, right? So in order to do that, we have to have a system in place to be able to capture these things when they occur. Otherwise, somebody might write it down or they might not, or we're going to pull everybody into a room at the end of a project that it was in execution for an entire year and then ask them what went right. I mean, what's going to go wrong in that meeting? Just about everything is going to go wrong in the meeting. No one's going to remember what went wrong. Something came up, and then they forgot about it later on. The project was successful, and you don't capitalize on those lessons learned. So if we can make it part of the culture, and we can make the lessons learned system accessible to everybody that's with the project, then they should be able to quickly update this capture system, we can call it, when things occur. Okay, and perhaps maybe you could do some incentive, I don't know. There's many different things that you can do to get the team to contribute to this. I find incentive works great. Otherwise, people just don't feel like doing it. It's another thing to do. So what I did was I created a form, and this form is, you link to it from a web page. User pulls it up. What category is this? What's the issue name? Problem, success, impact, and recommendation. That's it. Then they submit it. Where does it go? It goes to a sheet that looks like this, and this is an example of 3 of them that are filled out. So the data is captured from the form, automatically added to the system, remains there for later examination. So at the end of the project, we should have a finished list of all of these things, right? Which is much more beneficial than everybody sitting in a room going, what went right? What went wrong? Okay, so this is the way that I chose to plan this, and the system that I set up to track those things. All right, so let's take a look at a live demo of the project. So this is, hopefully everything works out. Data has also been added to the schedule. So I didn't just plan everything out and leave it alone. I actually statused some of this so that we can take a look at what the status of the project does to those automatic charts. And we can see how it all fits together. So let's take a look. Okay, so here we have my EVM dashboard. Okay, so I have embedded widgets here that basically are looking at charts that are, like I said before, tied to this chart, which is tied to other stuff. Okay, so it's all together. What I'm looking at now is the project charter. Oh, hold that thought. Okay, we're back. So it turns out I wasn't even connected to the internet. Okay, so we're looking for that. Now what I did was went to the link here for project charter, and here we are. So we saw in the PowerPoint presentation about half of this. Went through some of that. So what I didn't show was a lot of the milestones that are in here and basically tied to the schedule. Estimated costs and resources are all listed here as well. Some identified risks are here. The communication strategy is here. Very, very important to deal with this up front so that everybody that's going to be participating in your project understands up front what the requirements are going to be. Okay, how are we going to communicate as a team? How many meetings are we going to have? What am I going to be expected to contribute, etc. Also, a bunch of links to the different project resources that we already spoke about. So just moving through those rather quickly, let's take a look at the risk assessment. So the risk assessment, you could see pretty much everything that we looked at. These fields are automatically calculated. This doesn't feed anything. It's not really any different than any normal risk assessment that you've seen before. Okay, I have a automatic code thing that comes in here. It's basically just defining that this is a unique identifier. So if we have 2 risks that are very similar, we can actually look at the unique identifier and sort by that. That's all that really means. So now let's take a look at the budget. Same deal, it's all tied together. Budget doesn't feed anything, but this is essentially just an Excel file that exists in the cloud. That's all Smartsheet really is. Next thing we can look at is the project schedule. So this is the thing that really you couldn't get a good idea of what it really is when you're looking at the PowerPoint. What I've got is, and we spoke about this a little bit before, how I organized all of this. I have Sprint 1, Sprint 2, Sprint 3, 4, and 5, okay? So all of these, when they're expanded, they all are at the same level, essentially, in almost like a hierarchy. And that allows you to actually feed up by doing the sum of the children of each component. So when I look at the overall project values, I can get a sum of all of the children, which are all of the sprints. So that allows me to have a quick overview of everything that's going on in the schedule right in the same sheet, which is pretty nice. The other thing we've got here is this automatic Gantt chart creation that's going on over here. This gives everybody an overall view. Now, this looks completely different than what most people are used to seeing in Waterfall because of the lack of predecessors, number one, and number two, everything starts and ends with the same sprint. So you can see why traditional Waterfall, the Gantt is really useful, but for Agile, it's not. I mean, it's really not. Why have all that, or why create all that? It happens to be created automatically here. If I had to create that, I would say forget it, not for this. But that's just the way that this sheet was set up. So what we've got over here, we have who it's assigned to, the start and finish obviously are set up for the sprints. And the way that I organized the project was to first do the web. So that was a critical thing. Sprint 1 creates a whole bunch of different, so we have the architecture spec, the object model spec, setting up AWS, web hosting, getting all of that stuff set up so that you can collaborate with other developers that are at other companies, perhaps, outsourcing partners, etc. We have to have GitHub. We have to synchronize up to GitHub and then down to the user's machine. Okay. We also have different features that we need to scope out and we need to work on. We need to work on these user features and the underlying code for that. In Sprint 2, we get into the web UI. So user interface that's going to exist on the web, how that works, then the development of that, which is usually a little bit different. First we design it, we figure out what colors have to be there, what the icon needs to be, etc., how we want the look and feel to be for the user experience. And then for the development, we actually have to write that code. We have to write that CSS. We have to set that up. Then we have some back-end stuff to do. We have to connect this stuff to the database. We have to have web forms built. We have to connect those web forms to SQL DBs. We are the cloud server, all of that stuff. We have to develop the database. Also, we have to handle user access. We have to figure out how we're going to test the web UI. Okay, we have to worry about how we're going to test the database and the data entry and the recall of that data. So that's how Sprint 2 is organized. Sprint 3 and 4 are very similar, except one deals exclusively with iOS and one deals exclusively with Android development. The reason for that, there are expert developers in iOS, there are expert developers in Android. When you're outsourcing, the company will likely have both, and they're not normally the same person. So by separating the sprints up like this, I can actually reassign resources that are associated with Android, and those people can contribute to the team during that sprint, whereas the people that are iOS experts can contribute to the team when they're in Sprint 3. So that's the way that was organized. Sprint 5 is how do we bring all this stuff together. Okay, let me expand that. Okay, so now we have to test, right? We have project evaluation to do. We have deployment to do. We have deployment to the web. We have deployment to the Play Store. We have a launch to do. We have a social media campaign to do, etc. All of these things are things that you really need to look at when you're launching this type of an application. And then lastly, the backlog. You can see that my simulation ran up to July 10th. So we're simulating the project and what it looks like on July 10th. So you can see all of these things are complete. And you can see the backlog here has lessons learned and to capture those. Okay, and this is a typical. The backlog usually would be a little bit fuller, but because we're at the end of the project and the simulation, it's empty, and that's exactly what we wanted. So the last thing to do is to do the lessons learned here. Now, what we can do next is take a look at the Agile EVM, and we'll show you how this is tied together. So right now it says the actual percent complete is 95%, the expected is 85 because there's 6 days remaining in the release. Okay, so you can see the release end date 7/15, and this is the release start date 6/5. So let's go back to the schedule and let's take a look and see if we can make some changes that will change those values. So if I say that, well, we found out that we're not able to complete the test plan, so it's not started. Okay, now because that's not started, I actually don't have, let's see, what did it do? Oh, there it went, okay. So say that user story is not started. So the completed points now went from 3 to 0, which means that for sprint 5, the completed points overall dropped down to 9.4. The story points were 12.4. So we've lost 3. So what does that do to the overall EVM? Not much. Okay, it says expected percent was 85. I'm at 95. All right, let's lower it a little bit more. All right, now let's say that I'm not able to complete anything in sprint 5. All right, now what does that do? Okay, so let's take a look at what the difference is. Okay, so we've got some movement here. We have 92 points completed. The overall scheduled points were 108. So let's go back again, take a quick look at why we're not getting that data anymore. So in sprint 5, we've decided that we have not completed those. And then just for test purposes, let's say we've completed about half of them. Now you can see that we're at 91, okay, with 98.8. So you can see that this metric is actually tied to the project schedule. And then when we go back to our dashboard, we can take a look at the graphs and see if they jump around a little bit based on what happened with our schedule changes. Okay, so there we are. We've got what our schedule performance index is 1.4 and our 98.8 points completed and 108.4 planned. And you can see that our estimate and our actual percent complete is really, really high, much higher than what we expected to be at this point. Earned value, much higher than planned value. Okay, so that's basically how everything ties together. The last thing to look at would be the return on experience and the form that's set up to capture those things on the fly during project execution. So we'll load that up and take a look. So here's the actual, this is where the data is going to be stored, and then when you take a look at the form, we can link directly to this form. But when the link is clicked, this will come up. User can put this data in there as fast as they it's fast. It's pretty fast. Much better than trying to write something down than holding a meeting and capturing those things at that time. So once the data goes in there, it will automatically populate up here. We can try to do it. Let's see. Okay, so we can submit that. All right, so it's been added to the sheet. Now we can go back to the sheet later on at any time and refresh this, and we should see the new entry in there. Okay, there it is. So I have a scope in the category, my new issue, I have a problem, there's a big impact, I need to end the presentation. So this has gone long over what I expected, 10 to 15 minutes, but as you can see, this is the way that I set up the project. Very easy to navigate around, I mean, aside from the loading and such. And I hope everybody learned a little bit about the way Agile projects are executed and how you can also traditionally report EVM using Agile methodologies. So good luck to all, and good luck after graduation. All right, thanks everybody, bye.